Next up, let's look at another pretty large section, implement an authentication and access management solution. Passwords, no matter their complexity, used across devices, networks, and platforms are no longer sufficient to ensure the security of the user account, especially when users tend to reuse passwords across accounts. Sophisticated phishing and other social engineering attacks can result in usernames and passwords being posted and sold across the dark web. Azure Active Directory Multifactor Authentication, or MFA, helps safeguard access to data and applications. It provides an additional layer of security using a second form of authentication. Before starting the deployment of Azure Active Directory Multifactor Authentication, there are prerequisite items that should be considered. Make sure to pause the video to read the scenarios and prerequisites before you move ahead if you didn't already know these. Your MFA rollout plan should include a pilot deployment followed by deployment waves that are within your support capacity. Begin your rollout by applying your conditional access policies to a small group of pilot users. After evaluating the effects on the pilot users, process used, and registration behaviors, you can either add more groups to the policy or add more users to the existing groups. Azure AD Multifactor Authentication is deployed by using and enforcing policies with conditional access. A conditional access policy can require users to perform multi-factor authentication when certain criteria are met, such as all users, a specific user, a member of a group or assigned role, specific cloud application being accessed, the device platform, the state of the device, network location, or a geolocated IP address, sign-in risk, which to do that requires identity protection, compliant devices, or hybrid Azure AD join devices. And there's a few more, so make sure you review that link to cover those. The recommended way to enable and use Azure AD multi-factor authentication is with conditional access policies, which let you create and define policies that react to sign-in events and request additional access before a user is granted access to an application or service. Conditional access policies can be granular and specific with the goal to empower users to be productive wherever and whenever, but also protect your organization. Password writeback can be used to synchronize password changes in Azure AD back to your on-premises Active Directory domain services environment. Azure AD Connect provides a secure mechanism to send these password changes back to an existing on-premises directory from Azure AD. To enforce strong passwords in your organization, the Azure Active Directory custom banned password list lets you add specific strings to evaluate and block them. A password change request fails if there's a match in the custom banned password list. Azure AD includes a global banned password list. The contents of the global banned password list isn't based on any external data source. Instead, the global banned password list is based on the ongoing results of Azure AD security telemetry and analysis. When a user or administrator tries to change or reset their credentials, the desired password is checked against the list of banned passwords. The password change request fails if there's a match in the global banned password list. You can also edit this default global password list to put in your own values. To protect users, risk-based policies in Azure Active Directory can be configured that automatically respond to risky behaviors. Azure Active Directory identity protection policies can automatically block a sign-in attempt or require additional action, such as require a password change or prompt for Azure AD multi-factor authentication. These policies work with existing Azure AD conditional access policies as an extra layer of protection. Users may never trigger a risky behavior in one of these policies, but an organization is protected if an attempt to compromise security is made. There are many more details in each of these links, so make sure you do review them. Also, another video at the top, as we have many slides. As part of the sign-in experience for accounts in Azure Active Directory, there are different ways that a user can authenticate themselves. A username and password is the most common way a user would historically provide credentials. But with modern authentication and security features in Azure AD, that basic password should be supplemented or replaced with more secure authentication methods. Passwordless authentication methods such as Windows Hello, FIDO2 security keys, and the Microsoft Authenticator app provide the most secure sign-in events. Windows Hello for Business is ideal for information workers that have their own designated Windows PC. The biometric and PIN credentials are directly tied to the user's PC, which prevents access from anyone other than the owner of that PC. With public key infrastructure or PKI integration and built-in support for single sign-on, Windows Hello for Business provides a convenient method for seamlessly accessing corporate resources on-premises and in the cloud. Azure Active Directory lets you enable SSPR for none, selected, or all users. This granular ability lets you choose a subset of users to test the SSPR registration process and workflow. When you're comfortable with the process and the time is right to communicate the requirement to a broader set of users, you can then select a group of users to enable for SSPR, or you can just enable SSPR for everyone in the entire Azure AD tenant. When users need to unlock their account or reset their passwords, they're prompted for another confirmation method. This extra authentication factor makes sure that Azure Active Directory finished only approved SSPR events. You can choose from any of the following methods: mobile app notification, an app code, email, mobile phone, or mobile app. With Azure AD password protection, default global banned password lists are automatically applied to all users in an Azure Active Directory tenant. To support business and security needs, you can define entries in a custom banned password list. When users change or reset their password, these password lists are checked to enforce the use of strong password. You should use additional features like Azure MFA and not just rely on strong passwords enforced by Azure AD Password Protection. The Azure Active Directory Identity Protection Team constantly analyzes Azure AD security telemetry data for looking for commonly used weak or compromised passwords. Specifically, the analysis looks for base terms that are often used as the basis for weak passwords. When weak terms are found, they're added then to the global banned password list. In Azure Active Directory, there's a password policy that defines settings like the password complexity, length, or age. There's also a policy that defines acceptable characters and lengths for usernames. When self-service password reset, SSPR, is used to change or reset a password in Azure AD, the password policy is checked. If the password doesn't meet the policy requirements, the user is prompted to try again. Azure administrators have some restrictions on using SSPR that are different to regular user accounts. By default, an account is locked after 10 unsuccessful sign-in attempts with the wrong password. The user is locked out for 1 minute. Further incorrect sign-in attempts lock out the user for increasing durations of time. Smart Lockout tracks the last 3 bad password hashes to avoid incrementing the lockout counter for the same password. If someone enters the same bad password multiple times, this behavior will not cause the account to lock out. You can define the Smart Lockout threshold and duration. The Azure AD password policy doesn't apply to user accounts synchronized from on-premises Active Directory domain services environment using Azure AD Connect unless you enable the Enforce Cloud Password Policy for Password Synced Users policy. Azure AD Conditional Access analyzes signals such as user device and location to automate decisions and enforce organizational access policies for resources. You can use conditional access policies to apply access controls like MFA. Conditional access policies also allow you to prompt users for MFA when needed for security and stay out of users' ways when not needed. Microsoft provides standard conditional policies called security defaults that ensure a basic level of security. However, your organization may need more flexibility than security defaults offer. You can use conditional access to customize security defaults with more granularity and to configure new policies that meet your requirements. Security defaults make it easier to help protect your organization from these attacks with pre-configured security settings, such as requiring all users to register for Azure AD MFA or requiring administrators to perform multi-factor authentication. blocking legacy authentication protocols, requiring users to perform multi-factor authentication when necessary, and even protecting privileged activities like access to the Azure portal. Note, if you're using conditional access and have conditional access policies enabled in your environment, security defaults won't be available to you. If you have a license that provides conditional access but don't have any conditional access policies enabled in your environment, you're welcome to use the default security defaults until you do enable conditional access policies. Security defaults are great in some organizations, but many others need more flexibility. For example, they need the ability to exclude specific accounts like their emergency accounts or break last administrator accounts from CA policies requiring MFA. For those organizations, the common policies can be of use. Note the baseline policies in the graphic, those are also known as the security defaults that we just discussed. So take a quick glance at those before we move ahead. The access control portion of a conditional access policy controls how a policy is enforced. Grant provides administrators with a means of policy enforcement where they can block or grant access. Block access just does that. It will block access under the specified assignments. The block control is powerful and should be wielded with the appropriate knowledge. Session controls can limit the experience, such as use app enforce restrictions, use conditional access control policy controls, and there's two other categories such as sign-in frequency and persistent browser session. The assignment portion controls the who, what, and where of the conditional access policy. These include users and groups, cloud apps or actions, and conditions such as sign-in risk, device platforms, location, client apps, and device state. Report-only mode is a new conditional access policy state that allows administrators to evaluate the impact of conditional access policies before enabling them in their environment. When a policy in report-only mode is evaluated for a given sign-in, there are 4 new possible result values. Report only for success, failure, user action required, or not applied. The conditional access what if policy tool allows you to understand the impact of your conditional access policies on your environment. Instead of test driving your policies by performing multiple sign-ins manually, this tool enables you to evaluate a simulated sign-in of a user. The simulation estimates the impact this sign-in has on your policies and generates a simulation report. Make sure to review the Troubleshooting Sign-In Problems with Conditional Access article on Docs. It walks through several methods and ways to troubleshoot many common errors. People regularly use their mobile devices for both personal and work tasks. While making sure staff can be productive, organizations also want to prevent data loss from potentially unsecure applications. With conditional access, organizations can restrict access to approved client apps with Intune app protection policies applied to them. The following 3 scenarios describe the possibilities with application controls. In all 3 scenarios, all the users already sign in with Azure AD credentials and have licenses assigned to them that include Azure AD P1 or P2 and Microsoft Intune. In its first M365 scenario from Docs, Contoso has decided that all mobile access to M365 resources must use approved client apps like Outlook Mobile and OneDrive, protected by an app protection policy prior to receiving access. In the browser app scenario, Contoso decided that all mobile web browsing access to M365 resources must use an approved client app like Edge for iOS and Android, protected by an app protection policy prior to receiving access. Finally, in this third scenario, Contoso has decided that many users may only access email and SharePoint data on mobile devices as long as they use an approved client app like Outlook Mobile, protected by an app protection policy prior to receiving access. Within a conditional access policy, an administrator can make use of session controls to enable limited experiences within specific cloud applications. Conditional access app control uses a reverse proxy architecture and is uniquely integrated with Azure AD conditional access. Azure AD conditional access allows you to enforce access controls on your organization's apps based on certain conditions. The conditions define who, such as user, group, and users, and the what, which cloud apps, and where, such as locations and networks, that a conditional access policy is applied to. After you've determined the conditions, you can route users to the Microsoft Cloud App Security, where you can protect data with conditional access app control by applying access and session controls. Creating a session policy with conditional access app control enables you to control user sessions by redirecting the user through a reverse proxy instead of directly to the app. From then on, user requests and responses go through Cloud App Security rather than directly to the app. When a session is protected by proxy, all relevant URLs and cookies are replaced by Cloud App Security. For example, if the app returns a page with links whose domains end with myapp.com, the link's domain is suffixed with something like star.mcas.ms. While session controls are built to work with any browser on any major platform on any operating support system, we support Microsoft Edge and Google Chrome, Mozilla Firefox, or Apple Safari, and this would be the latest versions of all those. Access to mobile and desktop apps can also be blocked or allowed. Smart Lockout helps lock out bad actors that try to guess your user's password or use brute force methods to get in. Smart Lockout can recognize sign-ins that come from valid users and treat them differently than ones of attackers and other unknown sources. Attackers get locked out while your users continue to access their accounts and be productive. Smart Lockout is always on for all Azure Active Directory customers with these default settings that offer the right mix of security and usability. Customization of the Smart Lockout settings with values specific to your organization require Azure Active Directory P1 license or higher for your users. You can customize the Azure AD Smart Lockout values. Identity protection policies, we have two that can be enabled in an Azure AD tenant: sign-in risk policy and user risk policy. If an organization wants to allow users to self-remediate when risks are detected, users must be registered for both self-service password reset and Azure AD Multifactor Authentication. Organizations must decide the level of risk they are willing to accept, balancing user experience and security posture. Microsoft's recommendation is to set the user policy, risk policy threshold to high and the sign-in risk policy to medium and above. Choosing a high threshold reduces the number of times a policy is triggered and minimizes the impact to users. However, it excludes low and medium risk detections from the policy, which may not block an attacker from exploiting a compromised identity. Selecting a low threshold introduces additional interrupts, but increases security posture. All the policies above allow for excluding users such as emergency access or break last administrator account. Azure AD Multifactor Authentication provides a means to verify who you are using more than just a username and password. It provides a second layer of security to user sign-ins. In order for users to be able to respond to MFA prompts, they must first register for Azure AD Multifactor Authentication. Azure Active Directory Identity Protection will prompt users to register the next time they sign in interactively, and they will have 14 days to complete registration. During this 14-day period, they can bypass registration, but at the end of the period, they will be required to register before they can complete the sign-in process. Identity protection provides organizations with 3 reports they can use to investigate identity risks in their environment. These reports are risky users, risky sign-ins, and risk detections. Investigation of events is key to better understanding and identifying any weak points in your security strategy. All 3 reports allow for downloading of events in a CSV format for further analysis outside of the Azure portal. The risky users and risky sign-in reports allows for downloading the most recent 2,500 entries, while the risk detections report allows for the downloading of the most recent 5,000 records. After completing your investigation, you will want to take action to remediate the risk or unblock users. Organizations also have the option to enable automated remediation using their risk policies. Administrators have the following options to remediate: self-remediation with risk policy, manual password reset, dismiss user risk, or close individual risk detections manually. If you allow users to self-remediate with Azure AD Multifactor Authentication and self-service password reset in your risk policies, they can unblock themselves when risk is detected. These detections are then considered closed. Users must have previously registered for Azure AD MFA and SSPR in order to use when risk is detected.